Hey all, good morning, good afternoon, and good evening. So, my name is Hari, right? And I'm your PostgreSQL and Power BI trainer. I'm going to give an introduction about what we are going to learn, right? And how it is going to help us to crack a job, right? So, our training is PostgreSQL and Power BI. And this is going to be a Microsoft Power BI Data Analyst PL300 certified, right? So what is our objective? Our objective is to complete Microsoft Power BI Data Analyst PL300 certification and get the job. This is our first objective, to be precise, what we are going to try, right? And when we go in detail, what we are going to cover as a part of this course, right? There are majorly three blocks are there, right? Data warehousing, PostgreSQL, and Power BI, right? And we all are discussing, right? Whenever in the current world, everything is getting digitalized, right? That means there is no manual process. Everything is digital. When you go to a shop, the transaction happens digitally, right? You give the card, they will swipe it, and you will purchase it. Earlier in 90s, we give the cash, hard cash, and we would get the goods and we will take it. That's it. But in the current world, wherever you, whether it's entertainment, banking, logistics, everything we see one computer, laptop, or tablet, right? All our transactions are recorded in the system. With this, there is a huge amount of data, right? You would be heard about megabytes, gigabytes, GBs, right? And now we have terabytes and petabytes of data is there. Now the organizations which are globally, right, which is having a presence in multiple cities, how they can manage centrally, how they know their business is working in a right path or not. Then a lot of tools are there in the market. A lot of tools are there, right? And definitely the question comes, do we need to learn all the tools or any particular tool, right? So my honest answer is we don't need to learn all the tools, but whatever the tool we selected, that we should be expert in that one, right? When you go to any of the job profile open, you would be seeing a lot of technologies they mention. A person need to have so and so, so and so. On seeing that one, what we do is we will go to the online courses or we will join whatever we see. Okay, we got this some name. Let us start learning, right? But if we are not learning in depth of that course, then it is not going to help us, right? Select a limited courses, one, two, not more than three. Put your 100% efforts on that one. So accordingly, I have got this structure defined, right? Within this course also, I want to show you why we are not just completing the course with Power BI and why we have added PostgreSQL and data warehousing. Okay, so our course is like that. One class, like 10% data warehousing, we would be covering the fundamentals, right? Because to be honest, what I feel is that in any course or technology, we should be 100% strong in the fundamentals, right? We should not be having any doubts with respect to fundamentals because that is where it tells us what is my path, right? And that is followed by PostgreSQL, which is a database tool, right? Database management system. In this, we are going to learn the SQL, structured query language. Now, how we see English language, right, as a universal, right? If you learn English, right, you can manage to live in Europe, USA, and Australia, and many other countries. Similarly, if you learn the SQL structure query language, then you would be able to manage any kind of data with little practice. That is the reason I added the SQL. And it is going to be a 4 classes out of our 15 classes. And rest of the 10 classes, we are focusing on Power BI, which is a Microsoft tool, right? And why we need to learn all these three, let me show you the one simple diagram, data to insights, right? Now, if you see current technology, there are a lot of things are capturing the data, many things, sensors, systems, devices, automated device. When you are going in metro, right, the door, right, that opens and closes when we swipe it, we thought that it's just security, but it captures a lot of information, right? They will analyze at a particular hourly, they will do analysis, right? At what times that our station is busy and why? How can we manage the crowd? All those things. And that's the sensors. They capture how many people are coming. If you go to the shopping mall, a lot of sensors are kept near the entrance doors to count how many customers are coming. And what happens? All those things like see incoming data, whether it's event hub, streaming, right? And we have the databases. So SQL database, Microsoft SQL Server is a common database, but along with this one, we have Oracle, Teradata, PostgreSQL. These are all also databases, right? And we have machine learning. And if you see, this entire thing is going to be a data factory, right? And we are focusing on learning Power BI, becoming an expert in Power BI so that we will be going to visualize this data, right? So if you remember, right, a picture tells 1,000 words, right? Sentence may be a little bit, but if you remember, one picture tells 1,000 words. Now we have lots of data. It is sitting in the form of rows and columns or like in the files or somewhere. Now our job as a Power BI data analyst, we are going to give it a life of a visualization so that the users, either it can be executive committee members, management board of directors, or a mid-level managers or associates can easily interpret and they can take the decisions. Either it can be strategic or operational things, right? If you have any questions, you can put over the chat channel. Okay, I have kept it mute so that there won't be noise captured. Are we going to do Python or no? No, we are not going to do Python. Our focus is mainly on SQL, structure query language, and visualization tool, Microsoft Power BI, right? So any questions with respect to this end-to-end journey? Because I want to show you next one that is going to have what are all the tools that we can use in this journey. Now, if you see this journey, data to insights, that means there is a lot of data being generated. How we are going to manage this data? That is where we are going to. Yes, no, sir. We are going to record each and every class, right? And after the class, I'm going to upload this in the YouTube and access is provided to the registered students. Okay, so that the good thing with uploading in the YouTube is that you can watch this class recording at any time, anywhere. You can have a small notebook and capture the notes, and also you can start practicing. Okay, that's where. I have no background in IT. Can I participate in this class and get the certification and get a job? Eleanor, yes, to be honest, yes, you can be part of this group. Okay. Not much of the IT background is needed for this one because uh, The topic that we are covering is like from foundationals to the intermediate level. All I need is that whatever the assignments that I am giving to you daily basis, that you need to start working on it. Okay. And also if you feel that you want a refresh, yes, you can join the December batch also. Okay. If you are completely new to IT, I understand. To get comfortable with the new topics, it may take time. So that is the reason we are happy to continue in the next upcoming batches also. Okay. So there is no, with no extra cost or fees, that you can join the next December or January batch also. And whoever having completely new, yes, I am going to help you to provide the Microsoft Office trainings also as a complimentary. Right. Now, this is the concept. Now, our idea is that we want to convert data to the insights. Now, what are all the tools are there to do this job? Let me show you another diagram. If you see this one, right? And there are a lot of tools are there. Like if you see operational data, that means whatever we discussed, that is being captured, all the activities that we do as a part of our business. Suppose if you're in a banking domain, like capturing the transactions, capturing the loans amounts, capturing the customer activities, if we add this address, all these things, right? Now, once this operational data is there, that is going to be injected into the ETL. And we call this as a analytics. And if you see, there are like databases. We are going to learn about databases as a part of our course. Like it can be Cosmos, Data Diverse. And to do the data injection or analytical data storage processing, we have Azure data factories like Databricks, and there are Azure data lakes, right? And finally, we have data modeling and visualization. Now, our focus is going to be with the data modeling and visualization with the help of Power BI tool. And Power BI is not going to have a huge coding. It's a kind of a tool that helps that we can simply drag and drop the things and we can use it. Okay. And another interesting thing is people who has some hands-on with Microsoft Office tools, right? Right. Let me open the Power BI. I just want to show you one thing. The user interface, like the way the Microsoft Power BI tool is designed, it looks like just a next version to the Microsoft Office tools like MS Word, PowerPoint, Excel. Let me open a blank report. If you see the look and feel, like how we have tabs in the Microsoft Excel, similarly, we have different tabs in the Power BI also, like grouping the similar items. And in Microsoft Excel, right, we have these things, charts, where we create different kinds of charts, right? Similarly, similarly, we have visualizations here. So the one thing for selecting this course is the tool is developed by Microsoft, and they make sure that it is like a next brother to existing Microsoft Office, Excel, PowerPoint, all these things. So who are already having hands on all these things, I am 100% sure that you don't feel that you are learning a new tool. Just it's like you feel that, okay, I know this tool, I am just exploring the features of it, right? And As we are going to work on Microsoft Power BI, it's very important that how our source data is designed or how it is structured, right? We can't completely rely on our upstream teams. If in an organization, what happens is that they will say, okay, these are all the data models available, right? Or this is the table structures having so and so data. Now you start creating a visualization on top of it, right? As a Power BI analyst, that we should not be completely dependent on them. We should also have the capability to understand how it is built. That is the reason we are learning PostgreSQL and data warehouse, right? And why PostgreSQL? I'm going to give a detailed explanation in our second class, right? So our target is to be SME, subject matter expert in data modeling and visualization, right? This is our go-to target, right? Any questions till now before I explain you about the certification and the job market? Okay, I will take it as no. Coming to the certification now, right? And further, we have a detailed information about what are the topics we are going to cover, right? The same thing I provided over you in the mail also. Now, coming to the certification, as I told you, right, all our topics that we are going to cover in the Power BI, these are part of the certification curriculum, right? As a part of our core classes that we are going to complete 70% of the modules, those are to be completed as a part of our certification course, right? And the certification which we call is Microsoft Certified Power BI Data Analyst Associate, right? And as we going on our 15 days, guys, just to let you know, 15 days or 15 hours is not going to land us in a job, to be honest, right? But this will tells us what is our direction, right? 15 hours classes, after that a practice of 1 hour, and if you are able to understand, well and good. If you are having some difficulty initially, whoever new to the world, that you need to put some time, and I will also be there for you, helping in completing your assignments, right? After each and every class completed, right, I am going to send you an assignment like this. If I take a this one, yeah, right, with class number, topic we covered, and our batch month. And within this one, I'm going to provide you the class recording link and some links where you need to refresh. I mean, you need to read those articles and complete the assignment and send it back to me over the email by attaching the required file. Yeah, Arun, I will come, huh? So that I can understand how much you have learned. Okay, it should not be like a one way. Like if you have applied any online course, they completely teach you, but what you learn, no one is going to correct, assess you, right? So if you are able to, if you are completing your assignments, then I can understand and assess what is the level of knowledge you gained and what should I focus. Okay, so that is the reason this assignment is very important. Hmm. And along with this one, I am also going to send the meeting summary of the class. So this is generated by the Zoom, a artificial intelligence. So you can go through this one, what we have learned in today's class, right? Now coming back to certification, This is the certification, and if you see, the level is also intermediate. The reason, because to be honest, just learning fundamentals or foundation we are not going to crack. At least we should be having an intermediate level. So that is the reason I have taken this particular certification. And it is going to have 12 months frequency, that every 12 months we should renew our certificate, but it's a free of cost. It's just like that they want to know that we didn't forget the topics and we are there. Anyway, by that time, we should be landing in the job and we do our regular work. And in the certification, you have the prepare for the exam, practice for the exams. We can do n number of times. We can take multiple times practice exam. And if you are scoring above 80, that means yes, we are good in the to take the main exam, right? And these are the topics that preparing the data, model the data, visualization and analyze the data. These are the things that they are going to cover and they are going to measure. And if you see 1, 2, 3, 4, 5. So this is the training of this course. And as a part of our journey, we are going to cover majority of units here. But again, I make sure all my students are continuing with this learning, that you open this one, you would be having one chapter, two chapters, that you need to complete these two chapters. So we will get the score whenever we complete a module, and we can see total how much score you gain, right? And the course fees is $165, right? You can pay in your local currency, so that, and we have a dedicated team who can help you to get some discounts while registering this course. And also they would be guiding you to whatever the level of support you need. Okay, this is about the certification. Any questions with respect to certification? And this certification is good enough to make sure that our profile is being selected for interviews in the Power BI job roles, right? How do we renew? I mean, when we are completing within 1 year, obviously it will shows us pop-up that you are near to renew, or else we can simply click on this one, renew your certification. And renewal is free of cost, okay? It's not going to charge. They, it's just like that. It will again put a small test for us, right? Now coming to the job market. As I told you, right, nowadays, majority of the organizations are looking that who can present their data in a visualization form, because everyone want to know how their business is going to work. If you see, when I click on Power BI jobs in United States, I got 19,000 results, right? All are not going to perfectly match, but if I see some like Power BI developer, see, develop, maintain, and optimize SQL queries. That's what we are going to learn. To extract and manipulate data from various databases, we are going to learn. Create, manage Power BI dashboards and reports to visualize data trends and insights. Collaborate with stakeholders for the requirements. Perform data analysis to identify trend patterns, anomalies. We are going to learn. There are specific visualizations are there for each and every purpose. Stay updated to industry best practice. And furthermore, proficient in Power BI, including experience in DAX and data modeling, analytical and attention details, experience with data visualization, right? And if you see, knowledge of additional BI tools or programming languages is a plus, right? So if you see, many of you they are asking Python, or they are asking, that's, it's an advantage. But what I'm saying is, at a time we won't be able to learn all the tools, to be honest. So let us be proficient in one tool, land into the job, and then start exploring the new things, right? Data analyst entry level. So it will gives collecting and analyzing large data sets using variety of tools and techniques, identifying the trends. So as a part of our role, we are going to identify the trends and all those things. And we have a dedicated team, okay? They help you to prepare your resume and applying for the jobs also, right? And this thing we are going to more discuss when we are coming to the end of the batch. So our first thing is to mainly learn the Power BI, designing and developing Power BI reports and dashboards to meet the business stakeholders, proven ability to design, develop Power BI suites, gathering and understanding business requirements and data visualization, right? Job market is very huge, no doubt about it. And if you see the 6,000 to 9,000 per month, that's in Meta, Python, and based on the level of knowledge and experience we are going to apply, accordingly, the pay scale would also be there. But for Power BI, you are getting very good pay scale. Proficient in Microsoft Office and list of variant system softwares. 0 to 3 years of experience with familiar with BI tools, Power BI, Oracle, Tableau. SQL queries, SQL Server reporting, familiar with BI technologies, right? Like this, if I see this is another glass door, here also we have a good number of jobs are there, right? Here it is. And this is the experience level. We can filter out also based on the experience levels, right? Any questions or queries till now? Let me take audio questions also. Hey all. So as a part of our first class, right? So now we are going to see fundamentals, right? In our introduction in the webinar, right, we have seen the end-to-end diagram, right? This one. And we also seen this one. Now we are going to see what is the idea to get this particular picture, how this picture has came, like operational data, ETL, analytical data storages, right? I mean, what is the need to have this many levels? So we are going to discuss about those things, right? Starting with data warehousing, where it is, right? So whenever we are saying data warehousing, right? We all know warehouse, right? Warehouse is a place where we keep our goods, right? Or our either it can be a raw material or finished goods. The main purpose is that we want to make sure that external price shocks due to whatever the reason our raw material cost is suddenly increased due to break in the supply chain. Now, because if you see now we are having wars in the Middle East, right? Which means the oil that is supposed to deliver to oil consuming countries has a great impact. So that means whichever the companies those rely on the oil, suddenly their input bills would be increased. And we all know that, right? This is not going, I mean, these wars are not going to be long lasting. Definitely, there would be a time they would be stopping and things would be normalized. But how can we make sure that we are keeping that our input costs are not increased by maintaining a warehouse? Similarly, in the database world, right? We maintain data in the warehouse. so that we can take the copy of the operational data into the analytical systems. And let me show you one simple diagram for this one. Right? Let me take a simple diagram here. Insert pictures, online picture. So I'm just going to take you very simple basic picture. Okay, very simple one. Right? This is a very simple picture that shows the bigger one. Here it is. We have a bigger one, right? Now, if you see on the left side, we have different data sources, and these are operational systems. Now, what are operational systems? The systems, those help us to do our day-to-day transactions. Say I have gone to Walmart today, right? And I have done some purchase of items, and the cashier, right, who is sitting near the cash counter, he is going to scan all the products, and finally I will get a lengthy bill, right? And this entire information is stored in the online processing, online systems or operational systems. And we also call them online systems. The reason because they help us to complete all the online activities, right? Now, this is happening on a day-to-day basis, right? Now, at the same time, there are some backend team is sitting, right? What's their job is? Their job is to summarize whatever the transactions happen. Summarize. Just remember this word, okay? Our data tools are not as rocket science. What they do is they do the summarization, right? Now, what the backend teams do is they will start reading this data, they will summarize the data, and they show a picture. Okay, this is the total sales for today, total profit for today, or total sales for last 1 month, previous month, right? Now, to do this activity, a lot of processing power is needed, right? Now, the systems, those are already serving to the online customers, and there is another process hitting onto the same systems and doing heavy analytical processing. Now, initially, this is working fine. No problem with this one. The systems are capable of too. But as and when business is growing exponentially, right? What happens is that the existing systems are not capable and their performance is degraded very badly. Now, then it comes the idea, okay, how can we make sure that our online systems are making sure that they are focusing on the operational things, and I have a copy of the data so that I can do my analytical part. So this is the origin for these data warehousing things or visualization tools, BI tools, all those things. Now, what it is decided is they are saying that whatever the systems, those are helping to do the online transaction, we are calling them as online transactional systems. We simply call as OLTPs, online transactional processing systems, right? Because they helps in dealing with the online. Let me merge this cell. I think I need to merge another cell also. right? Now, as we know that when we are again doing an analytical processing on these systems, that the performance is very badly impacting, right? So what it came is that, okay, boss, let us don't touch the online systems when they are serving for the business morning 9 to 5, 9 a.m. to 5 p.m. or 6 p.m. Once your business closes at 6 p.m. or night 10 p.m., let us get a copy, one complete copy of what are all the new transactions those are happened, not about the historic. On day zero, I'm going to get a full copy of the data, right? On the day zero, that means the first day. Normally we term as day zero, the reason because we are going to get the entire existing copy. From day one, what are all the changes happened? Say what are all the new records came into the online systems? Those are captured, right? At the after the business hours. And we are sending that information to the warehouse. Now within the warehouse, we are maintaining in a three ways. One is maintaining the raw data. Raw data means exact replicate copy of this one, right? Say that we are taking a copy from there, and whenever we want to use that data for any analytical purpose, I am going to use it. Along with the raw data means completely a copy, maintains complete history of the data. A summarized data for the analysis purpose. A one classic example is what are our total sales, what is our total profits, how many new customers has came. These are the things. And a metadata. Metadata means information about what kind of information you are storing. Now, when you created a data model, right, the business want to know what kind of information we are maintaining because regulatories come into the picture that how we are maintaining our data. Are we storing the authorized data only? Suppose you are doing a banking, you are supposed to take a specific information like customer address, his income, right? His other financial information, right? And to some extent, you can take their medical history also. Suppose if you are giving any insurance, but if you are doing a bank, that also whether we are taking only the required information. So we also maintain metadata. Metadata means the information about what data we are storing. So whenever regulatory comes and asks, tell me what kind of information you are storing, that we will be referring to this metadata, and we are going to say we are storing as per our policies, right? So since we got a copy here, our analytical processing don't touch the operational systems, right? We are going to focus on our data warehousing. So that is the reason we call this as online analytical processing systems, OLAP, right? To be honest, be crystal clear with these particular topics. This is going to help us, no doubt about it. Okay, so we have one thing, online transactional processing systems that serves the operational things, and we have another system that is going to deal with the analytical processing. And our main focus is on the right side, right? And to achieve this one, we are going to refer the warehousing, where the data is stored in a summarized form along with the raw data. Actual data is also stored, right? Now within the warehouse, we are having some data marts. This is a terminology I'm going to explain you in detail. Now a data mart is also a subset of warehouse, or it itself a warehouse. Now data mart deals with each and every department. So within the organization, you have multiple departments, right? They work on their own activities, but at the same time, they are centrally integrated with the organization. Correct? So there would be some reports. Say if you have some HR team, they focus on how many employees are there, how many salaries we are giving to them, what is their holidays, how many working days they covered. So we can have a data mart for the HR system. Similarly, a data mart for purchasing system, a sales and inventory, right? So this is the end-to-end journey. And to complete this end-to-end journey, we have different kind of tools are there. To be honest, we are not required that we should be SME for all these things, but be a SME in your area and know what happens in other areas. That is the success of any IT engineer. They should have a full control of their tool and they should be capable of understanding what's happening in their upstream or downstream. That is where we are learning databases and understanding about the data warehouse, right? Now let us see a simple definition what it means by data warehouse provided by the Amazon, right? A data warehouse is a central repository of information, right? That's what we have seen here. Let me correlate this one. Central information repository that can be analyzed to make more informed decisions, right? See, once we analyze the historical patterns, then we can easily come up with the ideas. Okay, this is how our business is running. So that means this should be my strategy. Say my sales are increasing in the summer. Say you have a ice cream shop. Obviously, in summer you would be having more sales. So accordingly, we need to maintain our inventory. Correct? Data flows into data warehouse from transactional systems, relational systems, and other sources. That is what. So whatever you are seeing in the diagram, just that has put in the text. And I want you to read this one thoroughly and be familiarized with yourself. Typically on regular candidates, business data analysts, data engineers, data science, decision maker access the data through BI tools, right? See, there are a lot of names are there. Business analysts, data engineers, data scientists, decision makers. Let us be expert in one tool. Our target is to become business analyst with our Microsoft Power BI tool, right? Data and analysts have become indispensable to business to stay competitive. Business users rely on reports, dashboards, and analytical tools to extract insights from their data, monitor business performance, right? That's what we explained till now. And the reason why I'm showing you point to point is that, yes, you should not ignore this one. You should be thoroughly reading this one and understanding what is our objective, right? How is data warehouse architecture? So it is a three-layered one, right? A data warehouse made up of top tier, the front-end clients that presents results through reporting, analysis, and data mining. So if you see here, the front end, where we use the business intelligence tools to create the reports. The middle tier consists of analytical engine that is used to access and analyze the data, the warehousing and data marts. And finally, the bottom layer is the database, whether it can be databases or Hadoop systems or any cloud systems, right? What are the benefits of data warehouse? Like informed decisions, right? Just remember our data warehousing is going to be used to take the informed decisions. That means the accuracy is very important. right? Whenever we are storing our data, that we should maintain the data is accurate and there should not be any kind of discrepancies or errors should be there, right? Consolidate the data from many sources. That is the second thing, right? If you see in our diagram, we are consolidating all these sources into one place. Historical data analysis. Yes, I am going to maintain the raw data so that if I got a new requirement, I can refer this raw data. Data quality, consistency, and accuracy to be maintained in the data warehousing. Separation of analytical process from transactional databases, which improves performance of both the systems, right? This is the driving factor to have separate systems and separate, or else everything would be done in one system and one engineer would be fine, right? Now, some engineers will focus on the operational things, some engineers will focus on the analytical things, right? Similarly, we have data warehouses, databases, data lakes, right? There are some terminologies, right? Now, if I say simply files, we all know, right? If you want to store some data, what we do, we open a file, a notepad, and we store in it, right? It can be an Excel, it can be a notepad, right? Or it can be image. Image is also a file that is storing our image information. Similarly, 90%, I don't say 90%, 70% of our data requirements, like storing our data, manages by databases. And now these open source tools like Hadoop systems, distributed file systems, they also came into the picture, right? Now, in a database is like a house. So what I feel is that a database is like our house. Uh, Shapes. Normally, this is the one that uses, right? If I just correlate this one, if you consider this database is our house, then tables are like rooms. Say table 1, table 2, table 3. These are like rooms. And within these rooms, how we arrange our furniture, the data we arrange, right? So within our house, we are going to have a bedroom, kitchen, living room. And accordingly, based on the room type, the items would also be there. If it's a bedroom, you would going to have the beds. If it is a kitchen, you are going to have kitchen utilities. Similarly, if I say this is a customer table, I'm going to store customer related information, customer name, age, address, phone number, like that. And if I say this is a products table, what kind of products we are selling, then we would be having product ID, product name, product type, all those things, right? I'm going to save this file and let me share it with you. Locations, folder, desktop, data warehouse basics. Save data warehouse concepts. Yes. Okay. Similarly, like we seen data warehouse and databases, what is data lake? Now, within the database, right, we can see tables and columns. But if you want to store the files, images, notepads, then we go for the data lake. Just think of it. If you have the warehouse, properly racks would be there. You are going to arrange the things in the rack. But if you see the lake, right? Our lakes that flow in our country, lake can have any things, biodiversity. Similarly, data lake can store not only just databases, tables, but it can store images, files, blob data, online feeds, everything. That's called data lake, right? This is all about. Now, when it comes to the data warehousing, right? We have two great scientists, W.H. Inman and Ralph Kimball, right? So when this concept came that, okay, boss, let us separate, take a copy from the operational systems and you build a analytical warehouse, right? Then there are two great scientists. So they proposed two approaches. Now, how shall we build this warehouse? W.H. Inman and Ralph Kimball, right? Now, let us see what they proposed. And both the things are success. That is the reason we are learning them. Okay. So let's see Kimball approach. Now, Kimball approach to design data warehouse was introduced by Ralph Kimball. That's why he has kept his name, like how Newton has kept his name for the Newton theory. This approach starts with recognizing the business processing and questions that data warehouse has to answer, right? Now, what Kimball has suggested is, right, you have different systems are there, right? Say you have a database that stores the HR information. HR department is using it. Similarly, you have a database for marketing team and marketing team is used. Now, what Kimball has suggested that, hey, you just start creating a small data marts for each and every business line and then integrate with the organization, right? So I have HR department. Let us go and sit with the HR department, understand their business flow and create one data mart for them, right? As we know, data mart itself is a data warehouse. It's a subset. So like this, go on to the each and every department, create their own data marts, then integrate it into a data warehouse. Now, on top of it, whatever the reporting things you want, you just start creating that one. Now, Kimball's approach is setting build up and quicker. The reason because I don't need to worry about my entire organization. And this is like a your Scrum. I mean, if you someone has joined the Scrum and if you are already Scrum engineers, right? In Scrum, what it says is that first break the work into the meaningful, achievable blocks, right? And then start working on like creating definition of do and definition of done and working on it, right? And release the future, first feature, and then once it is success, take the feedbacks from that release and apply to the next one. So in this way, setting and building up is quick. Generating report against multiple star schema is very successful. Database operations are very effective, occupies less space. This is what Kimball suggested. Now, when it comes to the Inmon, right, let me show you the diagram for your easy understanding. What Inmon has suggested is, right, don't go individual departments. See from the enterprise level, right? Get all your departments on the single table, right? Understand the each and every department and create a data warehouse at the enterprise level, at the top level, so that all the systems data would be sitting in the enterprise level. right? Getting all the source systems, like hydrate all the source systems and create a data warehouse on top of it. Now give each and every department their own data mart, giving a copy to them, or giving a level of access that they can access their department level data and they can create their own departments, right? So which approach do you want to go with? Whether you want to go with the Inmon approach or Kimball approach? Just our thought. Okay, you can give. It's not like that you should be. Just what is your thought? Which one is the best you feel? Whether to start preparing our data marts and create a data warehouse, or s- create entire data warehouse and then give a copies of data marts. Which one you prefer? Arnold, NSC, Pola, Elena, Ismail, Kavita, Millie, no sir. Okay, no sir. You prefer Inmon? Happy? Hmm? So both are best fit. Okay, it's just about understanding our organization. Okay, and whichever the best fits, we can go with that one. Right? Now let us see some differences between both of them. Right? Now, if you see, introduced by Ralph Kimball and Bill Inmon approach, and trust me that we should be having a clear-cut understanding about this one. Then we can easily know why we are learning. Because even in Power BI, they suggest to have this one, right? Approach. It is a bottom-up approach for implementation, right? We sit with each and every individual department, and finally we will integrate to our enterprise level. It has a top-down approach. Data integration, it focus on individual business areas. It focus on enterprise wide. Build time, it is efficient and take less time, obviously, because we are dealing with each and every department. And it is complex and consumes a lot of time, right? Because see, understanding a complete organization, getting everyone to one place, right? Cost wise, it has a iterative steps and cost effective. Yes, we don't need to put upfront investment, lot of amount. It's just iterative. Initial cost is use and development cost is low. So here, if you see initial cost is use because you need to get everyone right into the onto the table. That means we need to pull everyone. So initial cost is high. But once we have a picture, the development cost would be reduced very low. It does not need a such skill, but generic team will do the job. Obviously, each and department and within the department teams, they can easily manage. It needs specialized skills to make work. Obviously, right? Because we should be knowing who can understand the end-to-end flow, right? Maintenance. Here, maintenance is difficult, right? So the negative point for Ralph Kimball is maintenance is difficult. The reason because you would be having multiple data marts. Say in the HR department, you would be having one employee table. Similarly, in the sales department, you would be having one employee table, right? So like this, similarly, you would be having a product table in the sales data mart. And there would be another product table in the inventory table also, inventory data mart also. Like this, what happens? You can have multiple tables of similar kind of information. So the maintenance is difficult. And Inmon has the advantage here. Here the maintenance is easy because centrally we know what are all the tables to be maintained. So we can avoid the duplicates, right? It prefers data to be denormalized model. It prefers data to be normalized model. Now, what it mean by? Guys, I want your attention here because we are using a terminology called denormalized and normalized. What it mean by? Okay, this is very, very important as a part of our learning journey because this topic is going to come in every turning in every one of our learning, right? I hope you are all with me. Can you raise your thumbs up or just ping? Thank you. So what is the meaning of denormalize and normalize, right? For this one, what I did is I have created some data to explain you this one. Let me open that one. I'm going to share all these things with you. Mm, Where is the normalize? Yeah. So if you see this table, right? This is a transaction table. Okay. So when you see it, this particular transaction table, right, it is having the product name, customer address, and the more details about his purchases. Correct? Now, if you see this particular table, if the Harish is the customer, say he is regularly visiting that particular store, right? Then his information is going to repeated. Say if I visited 10 times, my information is going to be stored 10 times. Like me, there would be 1,000 or 1,000,000 customers who frequently visit that store, right? So, like Michael, again, he has visited. Similarly, the product name, same product name is going to be, right? So, the concept of storing complete details in a single table is called denormalization. Transactional and operational data are more or similar, Aaron. Okay. Normally, what happen? The transact activities, whatever we do, the we call it transactional, and day-to-day operations, right? That happens. Both are similar. Okay. There is not much of the difference. Just the context changes. Okay. If you are working in manufacturing industry, then we say it's a operational data. When we are in banking terminology, we say the transactions data like that. Okay. Now, when we are storing majority of information related to the products, customers, or what kind of transactions happen in a single table, then we call it as a denormalized. Now, what happens with the denormalized? The data storing is repeated. That means we are storing redundant data, right? And we all know, right? The disk space or the disk is costly, right? We should pay for the space we are utilizing. Even nowadays, if you see our Google Drives or Microsoft Drives, they are also asking us to purchase the space like monthly 100 rupees or 150 rupees, whatever it may be, right? So when we are paying that, we need to make sure that we are storing the right level of information, right? If we are storing redundant information, we are paying money for that one means we are losing, I mean, we would be having impact on our profits. Correct? So now what it is decided is, okay, boss, wherever I feel a particular information would be stored repeatedly, I'm going to create a separate tables for them. Say in the transaction table or in the sales table that I would be referring the customer ID multiple times or product ID. So let me create a table, customer table, like customer profile table. Similarly, a products table. Now what I'm going to do is I'm going to create a products table where I'm going to maintain one record for each product. Similarly, a customer table, one record for each and every customer. If there is any change in the customer attributes, then I'm going to inactive the old record and create one new record. So that means I'm going to have a unique active records for the customers or products. Now I'm going to refer these unique identifier in the transaction table. Now if you see earlier per customer address, I'm storing some 20 MB. Consider, okay, one letter is 1 MB. Now I'm going to store 1 MB only, right? So in this way, what I'm doing is I'm reducing the data redundancy, right? By storing the information in multiple tables, right? I'm able to reduce the space utilization almost by 10 times, right? It can be more than 10 times also based on the way we store, right? So the process of storing data in multiple tables and creating a relationship between them is called normalization. So when I'm referring a transaction to, right? So if I want to know what is the product and customer ID, then what database will do is it will figure out, okay, product ID is linked to the products table. So for product one, these are the details, right? And during the online systems or operational system, they go with the denormalized because at that time customer needs the information and we know, right, in the online systems we don't maintain the history, we maintain the current transactions only, whereas when it comes to the analytics where we maintain the complete history, so to avoid storing data redundantly we go with the normalized. Got it? In the current business world, right, for all the analytical systems are maintained in the normalized form where data is distributed in multiple tables and they have the relationships. That is called relational database management system. And to show this in a pictorial form, let me open another article for you. And this article is from our Power BI as a part of desktop model, right? And whatever we explained, right? If you see this particular diagram, right? If you see this particular data, our sales table is referring customer address table, customer profile table, and products table, right? So our sales table is sitting at the center and it is going to refer product table for detailed product information, date table for date, customer table for customer, right? So what happened? And if you see how it is look like this. So when we store our data in a normalized form, we would be having a table at the center that is going to refer the multiple different tables, right? And this looks like a star, so we call it as a star schema. The center table is called as a fact table. So fact table is going to store the facts about the transactions, observations, and all those things. And the surrounded tables are called dimensions, which stores the details about your product's dimension, customer dimension. We call, right? Hey, what are all the dimensions of that product? Length, breadth, height. Similarly, for this fact table, you have a product dimension that is going to have product in detail information about the product. You have a customer dimension, in detail information about the customers, right? So the center table is the fact surrounded by the dimension tables, and we call it as a star schema because it looks like a star. Any doubts still now about the normalization and denormalization? I'm happy to repeat this one again because we should be very clear with the fundamentals. Even if I wake up you at the midnight, that you should be in a position to tell me what is star, what is snowflakes. Are all data stored in these shapes? Yeah, see, this is a logical representation, Unis. Okay. They would be stored in the tables and the tables are related like this. Okay. And if I scroll up here, it's unusual for a Power BI semantic model to be comprised of single table. A single table model can be simple, perhaps one that's suitable for data exploration, but not one that an optimal model. An optimal model adheres to star design principle. And star schema refers to the design approach that commonly used in relational data warehouse designers. It presents a user-friendly structure and it supports high-performance analytical queries, right? And to be honest, this concept of data warehousing, star, snowflake schema, they are introduced in around 1986, like that, 1980s and 90s. But still, whatever we are saying, machine learning, artificial, everything, the underlying base is this one only, right? A detailed explanation about fact. The role of fact table is store an accumulation of rows that represents observations or events that record a specific business activity. And if yes, what tools they use to query them databases. Uh, yes, Kartis, as I told you, right, for operational systems and where they don't maintain a history, right? In operational systems, what we need to know, the latest information, correct? Suppose if you go to the bank and if you give your customer address, they are going to pull your latest information only, right? So for operational information where latest information is needed, there the normalize is going to be used and it is also stored in the database. Ultimately, all these things are stored under the database only. Whether it can be of any database. Okay. Like stock, currency, exchange, general. Similarly, dimension table describe the business entities, which commonly represents people, places, products. Right? One row for each date is a common example. Right? See, dimension stores, simple, remember, dimension table stores about information about the objects, organizations, persons, individuals. Fact tables are going to store the events, whether it can be a transactions, observations, sense or recording, all those things, right? So that is the reason normally fact table rows changes very frequently, whereas dimension table rows changes very slow. Like if you have a branch table, right? We are not going to add more and more branches. Initially, we may, whenever we have an expansion plan, branches would be added, but later on, it would be a static one, right? Data volumes typically contains fewer rows, contains numerous rows. Query purpose to filter and group to summarize. right? So now when I step back, who is responsible for data schemas, DBS or data analyst? It's a DBS. Huh? So data analysts are like a end users for the data schemas, and DBS like data injection, who are going to do data injection, they will focus on the data schemas. Okay. And DBS also helps in maintaining the performance of the database systems. They guide us whether the queries we are running are optimized or not, right? Now, if I step back from the fact table and dimension table and come to here where it is. Yeah. So when we say normalized, denormalized, we seen what is about star and snowflake schemas. Star schema we have seen, right? Data store systems, source systems are highly stable, right? Since it is a Kimball, we are dealing with each and every department. We don't add more source systems, but when it comes to the enterprise, you may add new departments or new systems. So the source systems would be changing, right? Now, if I come back to here, right? So we have seen introduction, we have seen OLAP, OLTP, Inmon and Ralph Kimball, data marts and data warehouse we have seen. Star schema we have seen, snowflakes we have not seen. Let me explain that one. Data normalization and denormalization we have seen. Dimensions and fact tables we have seen, right? Now, as we know, right, we have seen here the star schema, correct? Now, when we say our fact table is connected to the customer address dimension table, right? Now, again, within the customer address table, if you know the city name and state name, they are going to repeat, right? If you take a city like Texas, we would be having some 1 million customers. So that means Texas is going to be repeatedly writing. Similarly, state USA. Now, what we can do is we can further break down this customer address table into the address table and the city table, where we are going to give a unique identification number for each and every city and just refer this city ID, right? So what happened here? Parent, child, grandchild kind of relation, right? So whenever your relation further links to another table, right? Say here. Now your fact table is linked to product table. Now if this product table again referring to another product category table or product type table, right? Then it becomes a snowflake, right? So if it is a one level, then it is a star schema. But if your dimension tables are further referring to another dimension table, then we call it as a snowflake schema. Okay. So this is all about our course and introduction. So tomorrow we are going to learn about PostgreSQL database, right? We are going to see how to install it. And there are two ways are there, graphical user interface and command line. We would be seeing both approaches and creating a database and a table, right? So let me stop the class for today.